Hey, so what I want to do in this video is just do an overview of probability. First of all, I'm really sorry this didn't happen sooner. I meant to do this on like Thursday in the week, just got away from me. So after watching this video, if you still are feeling stuck on probability, please meet up with me. Okay, we can meet up on Zoom someday and go over some specifics. Okay, for now, let's go ahead and go to the whiteboard. Okay, so first of all, we need to know what probability is. So probability it's the measure of how likely something is to occur. Okay, so how likely is something to occur? We measure probability as a number between 0 and 1. Zero is never going to happen. Okay, so this will never happen. 1, if we assign a probability to something of 1, that means it's absolutely going to happen. This is a certainty. Okay, and basically the way this works is the closer to 0 something is, the less likely it is to occur. The closer to 1, the more likely something is to occur. So if you had something that had a probability of 12, we would say that's not very likely. Okay, if you had something that had a probability of 75, that's fairly likely. Okay, so again, the closer to 0, the less likely. The closer to 1, the more likely. We can also write probabilities as percentages. So it would be 0% to 100%, or we can write probabilities as fractions. Okay, so you won't necessarily always see it as, there we go. You won't always see it as necessarily a decimal. So like if we're dealing with a number between 0 and 1, that would be a decimal. That decimal can easily be converted to a percentage or a fraction. So any of those three representations are equally likely. Okay. Now, in EdReady, I did notice they had a couple of problems where they go over outcome, trial, and event. So basically, you need to know what these definitions are. Think of the trial as like the experiment. What are we doing? You could have a trial where you're rolling a die. You could have a trial where you're flipping a coin. You could have a trial where you're drawing cards from a deck. You could have a trial where you're selecting marbles from a bag. So again, the trial is kind of like the experiment. What are we doing? Okay. And then from the trial, we have to know what are all the possibilities. So the possibilities are the outcomes. So this would be all possibilities. So if we are rolling a die, it would be numbers 1 through 6. If we're flipping a coin, it would be heads or tails. If we're drawing from a deck, that's a little bit more extensive. When you're drawing from a deck, you have any of 52 cards. When you're selecting different colored marbles from a bag, it would be all of the marbles. Okay, so the trial is kind of like the experiment. What are we doing? The outcomes are all possibilities. Whatever the trial is, what could occur? And then finally, you have the event. So it's one isolated possibility. Okay, so rolling a die, we could have, what is the probability of rolling a 2? What is the probability of rolling an even number? What is the probability of rolling a number greater than 4? Okay, if we were selecting cards from a deck, we could say, what is the probability of selecting hearts? What is the probability of selecting a face card? What is the probability of selecting a red card? Okay, so again, trial is kind of like the overall experiment. An event is one possible event or outcome that would occur in that. And then the outcomes are all the possibilities that could occur. Okay, so far we know what probability is. It's the measure of how likely an event is to occur. It's a number between 0 and 1. The closer to 0, the less likely the event is. The closer to 1, the more likely the event is. And then we've got trials, outcomes, and events. Again, trials kind of like the overall experiment. The outcome is all possibilities for that experiment. And an event is like one isolated possibility. So what is the probability of one thing occurring? Now, the next thing you need to know does not come up all the time, but it does come up in Ed Ready. So I want to make sure I cover it. And it is the fundamental counting principle. Okay. And basically, the fundamental counting principle helps us come up with all of the possible outcomes when you're dealing with 2 or more events. Okay. So basically, if one event has P outcomes and another event has M outcomes, then the total number of outcomes for the 2 events is P times M. Now, this could be expanded if you had a third or a fourth or a fifth event. You just take the outcomes for each event and you multiply them. This comes up when you're looking for different combinations. Like sometimes problems will be like choosing a meal at a restaurant. Let's say there's 4 entrees, 2 sides, 3 desserts, and 4 drinks. How many different ways could you order your meal? Another classic one is choosing outfits. Okay. So let's say we're choosing outfits and we have 3 shirts. We have, let's say we have white, green, I don't know, blue. Let's say for pants, we have 2 pants. Let's say we have jeans and khakis. And then let's say we have 2 pairs of shoes. So let's say we have sneakers and boots. I don't know. I'm pulling this out of thin air. So basically we would not want to know, okay, considering the number of, that's supposed to be shirts. So considering the number of shirts, pants, and shoes that we have, how many different outfits could we create? Well, for the shirts, we have 3 outcomes. For the pants, we have 2 outcomes. For the shoes, we have 2 outcomes. If we multiply this out completely, we get, let's see, 3 times 2 is 6 times 2 is 12. So we could create 12 outfits. So an example of one outfit could be jeans, a blue shirt, and sneakers. So that's one of the 12 outfits, okay? So keep the fundamental counting principle in mind. It's not hard to use. It can just sort of throw you because all of a sudden you need to use it and maybe you don't know what it is. So with that said, let's start looking at examples, okay? So we're going to look at some pretty easy examples and we'll kind of work our way up from there. So first, let's say that the trial is that we're going to be rolling a 6-sided die. Just one of them. So an event we're looking at is what is the probability of rolling a 2? Well, when you're dealing with probability, you always are looking at this as a fraction. So we generally look at ours as a fraction in a math class. And so the way the fraction is set up is the denominator is all possible outcomes. Okay, so if we're rolling a fair 6-sided die, we could land on 1, 2, 3, 4, 5, or 6. So there are 6 total outcomes. Okay, and then the numerator is always the outcomes for that event. Well, we're looking at rolling a 2. There's only one way to roll a 2, so the probability of rolling a 2 is 1/6, okay? We could look at the probability of rolling an odd number. So this is the event. So again, the trial is rolling a 6-sided die. The event is the probability of rolling an odd number, okay? So again, the total outcomes, we're still rolling that same 6-sided dice. The total outcomes are 6. But then we have to look at the probability of rolling an odd number. So how many outcomes do we have for an odd number? Well, we could roll a 1, a 3, or a 5. So we have 3 possible outcomes that are odd numbers. So the probability here is 3/6, or always reduce it and we get 1/2. Let's look at one more. What is the probability of rolling a number greater than 2? Okay, so again, we're rolling that same fair 6-sided dice. There are 6 total outcomes, but then we want to look at the outcomes for this particular event. How many ways could we roll a number greater than 2? Well, we could roll a 3, a 4, a 5, or a 6. So there are 4 possible outcomes for the event of rolling something greater than 2. So the probability is 4/6, or it reduces to 2/3. Okay, so that's pretty basic. Again, when you're calculating a probability, you need to know all of the possible outcomes, everything that could possibly occur. That's always the denominator. And then the numerator is always the outcomes for the particular event in question. And then you do want to reduce your answer. All right, so let's look at another example. So for this one, the trial is we have a bag of marbles. In the bag of marbles, we have 6 red, we have 8 blue, we have 4 yellow, and 2 green. So the first thing I want you to do is figure out how many marbles do we have total. Well, if I add 6 plus 8, I get 14, plus 4 is 18, plus 2 is 20. So we know we're dealing with 20 marbles total. So the total number of outcomes is going to be 20. And again, if we go back to that previous slide, right here, probability, it's the number of outcomes for a specific event divided by all total possible outcomes for that trial, okay? So in this particular case, the outcomes for the trial, 20, okay? Now, let's look at an example. So what is the probability of selecting red? Well, the probability here, we know the total outcomes are going to be 20. Okay, we have 20 marbles, so the total outcome is 20. And then the event that we're looking at is just selecting a red. So how many ways can we select a red? Well, 6. So the numerator is going to be 6. So the probability of selecting red is 6/20, or remember, we want to reduce, so we would say 3/10. And that's our probability. Let's look at the probability of selecting yellow or blue. Okay, so again, for this particular trial, selecting marbles out of a bag, we have 20 total outcomes. All right, and then we want to look at the outcomes for this event. So selecting yellow or blue. Well, we have 4 yellow, we have 8 blue. So in this case, the number of outcomes for this event, yellow or blue, would be 8 plus 4, or 12. So there are 12 different ways I could select a yellow or a blue. So my probability is 12/20, or if I reduce it, let's see, these are both divisible by 4. So I would get what, 3/5? And that's it. So that's my probability of selecting a yellow or a blue. One more. Let's look at the probability of not selecting green? I'm going to reword it because it sounded a little crazy. So what is the probability of selecting anything but green? There is a situation where you do a not probability, but that doesn't really come up from what I could see in our ed ready, so I don't want to add confusion. Okay, so what is the probability of selecting anything but green? Well, we can see here that we have 2 greens, okay, and we have 20 marbles total. So what's the probability of getting anything but green? Well, we have, again, the probability, we still have 20 outcomes total. And of those outcomes, 2 are green, but we don't want green. We want anything but green. So there are 18 other marbles besides green. So the probability is 18/20ths or 9/10ths. All right. So let's look at another one. So in this case, we have lunch boxes. There we go. So we have lunch boxes. These lunch boxes, you have 2 options for a sandwich, you have 3 options for a side, and 2 options for a drink. So basically, we can choose ham or turkey. Those are the different sandwiches. The side items are cookies, pretzels, or an orange. The drink options are water and juice. So let's say you select a meal at random. So you select a box at random. What is the probability of choosing a box with pretzels? Okay. Well, the first thing we have to figure out is how many possible boxes do we have? Okay. How many different combinations do we have here? So let's go back to the slide where we talked about the fundamental counting principle. Remember, the fundamental counting principle helps you figure out the total number of outcomes where you're dealing with multiple events. Okay. So if one event has P outcomes and another event has M outcomes, then the total number of outcomes for the 2 events is P times M. Okay. So we're going to kind of utilize that here. Okay, so the total outcomes, well, for the type of sandwich, we have 2 options, ham or turkey. For the side items, we have 3 options, pretzels, cookies, or oranges. And then for the drinks, we have 2 options, water or juice. Okay, so if I multiply these out, I'll get the total number of combinations that we could come up with. So 2 times 3 is 6, 6 times 2 is 12. So there are 12 different boxes or 12 different outcomes. And what we then have to do is figure out, okay, if we know we have 12 outcomes, what is the chance that we'll get an outcome that has pretzels? So the probability here, we know the total number of outcomes is going to be 12. We then have to figure out the total number of outcomes for the specific event of getting pretzels. So how many outcomes are there for pretzels? Well, I could choose ham, pretzels, and water. I could choose ham, pretzels, and juice. I could choose turkey, pretzels, and water, or I could choose turkey, pretzels, and juice. So it looks like we have 4 outcomes total that involve pretzels. So of these different meal lunch boxes that you could choose, 4 out of 12 would involve pretzels, or 1/3. And there you have it. So that's a probability that does include that fundamental counting principle. Okay. Now, another thing I noticed in Ed Ready is they do something where you have rolling 2 die or 2 dice. Okay. So if you're dealing with a trial where we're rolling 2 6-sided dice, you have to know what the outcomes are. And this can be a little tricky for students. So I want to go ahead and lay it out for you here, and then we'll answer some questions. You've got these two different die, you're rolling them, or these two different dice, you're rolling them together. You could roll a 1 and a 1, a 1 and a 2, 1, 3, 1, 4, 1, 5, 1, 6. You could roll a 2 and a 1, a 2 and a 2, 2, 3, 2, 4, 2, 5, 2, 6. And I do want to point out, like right here, this 2, 1 and this 1, 2, those are different outcomes because the first die is a 1, the second die is a 2, or the first die is a 2, the second die is a 1. So even though they're really the same at the end of the day, in this particular situation, they would be considered different. Let's see, we could have a 3, 1, 3, 2, 3, 3, 3, 4. Let me fix that 4, it looks stupid. 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And then finally 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So when you're dealing with two 6-sided dice, there are 36 outcomes total. Okay. And so generally I don't want students to have to sit and write down every single possible outcome because depending on the trial, it could get out of hand. But two 6-sided dice, it's worth understanding what those outcomes would look like. This is what those outcomes would look like. So now let's look at specific events. Let's see, what is the probability of rolling doubles? Okay, well, we know that the total number of outcomes is 36. We have literally laid it out right here. Doubles, let's see, doubles are when you have the same number on both of the dice. So I've got 6s, I've got 5s, 4s, 3s, 2s, and 1s. So for this particular event, there are 6 outcomes. So the probability of rolling doubles would be 6 over 36, or if I reduce, 1/6. Okay. B, this is one where it would be really nice to have the outcomes sitting in front of you. So if in EdReady you saw something like the question I'm about to present to you, it's worth taking a minute or two to write out all these outcomes so you can see it a little better. So what is the probability of rolling a sum of 8 or more? Okay. Eight. 6 and 3 is 9, 6 and 4 is 10, 6 and 5 is 11, 6 and 6 is 12. If I look at 5 and 6, that's 11, 5 and 5 is 10, 5 and 4 is 9, 5 and 3 is 8. If I look at 4 and 6, that's 10, 4 and 5 is 9, 4 and 4 is 8. And then looking at the threes, let's see, I get 3 and 6 is 9, 3 and 5 is 8. And then looking at the twos, 2 and 6 is 8. So right here, circled in green, I have all the possible outcomes for the event of rolling a sum that is 8 or more. So the probability is all possible outcomes. We have 36 different ways we could roll 2 dice. Now, out of the rolling a sum of 8 or more, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 ways that we could roll a sum of 8 or more out of 36. Okay. So we want to look to see if we can reduce this. Okay. So numbers that 15 and 36 have in common, let's see, they're both divisible by 3. 15 divided by 3 is 5. 36 divided by 3 is 12. So the probability of rolling 2 dice and getting a sum of 8 or more is 5/12. So again, 36 total outcomes, that's always going to be the denominator. And then the number of outcomes for a specific event, that's the numerator. We had 15 ways we could roll 8 or more. Reduce it and you get a probability of 5/12. Now, another thing I saw in Ed Ready is they talk about rolling a die and flipping a coin. So that's going to be our trial. We're going to be rolling a 6-sided die and flipping a standard heads, tails coin. Now, one thing that's a little tricky here is this word and, okay? So it all depends on the type of statistics class you're in. Like if you were to take a math 143, you would talk about this a lot more in depth. 121, 171, you're never going to see this. Okay, so I just want to gloss over this real quick because it's not really going to hit you hard. But when you're dealing with an and probability, what is the probability of this and this? You always want to multiply the outcomes. So if I have the probability of event A and the probability of event B, generally speaking, it's going to be the probability of A times the probability of B. Now, there's more to this if you take, that Math 143 class where you have a much more in-depth unit on statistics. This is definitely going to come up if you take the actual statistics class. But for this class, we just need to gloss over the possibilities here, okay? So you take the probability of the first, multiply it by the probability of the second, okay? So kind of keep this in mind, okay? Now, let's look at a couple of examples. The first one is, what is the probability of rolling a number less than 3 and landing heads up? So as far as the coin is concerned, we're going to be looking at rolling a number less than 3. As far as flipping the coin is concerned, we're interested in landing heads up, okay? So for the probability of rolling a die, now we know if we're dealing with a standard 6-sided die, the total number of outcomes would be 1 through 6, okay? So we have 6 total outcomes, but looking at this specific event, what is the probability of rolling a number less than 3? How many ways can we roll a number less than 3? Well, there's rolling a 1 or there's rolling a 2. So there are 2 outcomes for rolling a number less than 3. Now, flipping a coin, there are 2 ways you can flip a coin. You can flip it heads up, tails, or landing on tails. So that's 2 possible outcomes. Of those 2 outcomes, how many ways can you land heads up? Well, just 1. So we would multiply across and we get 2/12, and then we want to reduce that and get 1/6. So the probability of rolling a number less than 3 and landing heads up on flipping a coin would be 1/6. Next up, let's say, what is the probability of rolling an even number and landing tails up? Okay, well, let's look at rolling an even number first. We know that when you're dealing with rolling a die, there are 6 outcomes for a single die. Of those, how many ways could we roll an even number? Well, the even numbers that are 1 through 6 would be 2, 4, 6. So we have 3 possible ways to roll an even number. Flipping the coin, we have 2 possible ways that that coin can land. And how many of those ways is landing tails up? Just 1. We multiply across. 3 times 1 is 3. 6 times 2 is 12. And then we simplify. 3 and 12 are both divisible by 3. So the probability of rolling an even number and landing tails up is 1/4. Okay. So let's see, I've got one more example. So in this case, the trial is we're going to be rolling a 6-sided die and flipping 2 coins. So similar. All right. Now, keep in mind we have the word and, so we're going to do like we did in the previous example where we're going to take the 2 different probabilities and multiply them. So for this one, we want to know what is the probability of rolling a number greater than 3 and landing heads up twice. Okay, so looking at just the coin, again, we're dealing with a single six-sided die, so we have 6 total outcomes. And then we have to look at the probability of this particular event, which is rolling a number greater than 3. So when you're dealing with a 6-sided die, how many ways can you roll a number greater than 3? Well, you could roll 4, 5, or 6. So we have 3 outcomes for that event. And then we're flipping 2 coins. So for the first coin, we have 2 outcomes and we want to land heads up. So there's 1 out of 2 ways to do that. For the second coin, we're landing heads up. So probability for each of those is 1/2. We multiply all the way across. 3 times 1 times 1 is 3. 6 times 2 times 2 is 24. So the probability of rolling a number greater than 3 and then both coins landing heads up is 3/24, or it reduces to 1/8. All right. Next up, let's see. We want to know, what is the probability of rolling a number less than 5 and then rolling and then landing heads up on the first coin and then tails up for the second. Now, you do have to be careful when you're dealing with flipping a coin, because you could flip 2 coins at one time, or you could flip a coin twice or flip 2 coins separately. So it all is going to depend on the wording. If we were taking 2 coins and flipping them at once, the outcomes would be totally different. If you're taking a coin and flipping it and then taking another coin and flipping it, it's going to be these independent probabilities like what you're seeing here. So just keep in mind, we're flipping 2 coins separately. That was my intention. I just didn't word it very clear at the beginning. Okay, so let's look at the coin or the dice first. So we're rolling a fair 6-sided die. So we have 6 total outcomes. But then for this particular event, we're interested in a number less than 5. So how many ways can I roll a die and get a number less than 5? Well, I could roll a 1, a 2, a 3, or a 4. So there are 4 possible outcomes. For the first coin, we want to land heads up. So there's 2 outcomes. One of those is heads. Second coin, tails up. There's again 2 outcomes. One of those is tails. So we multiply all the way across. 4 times 1 times 1 is 4. 6 times 2 times 2 is 24. We reduce and we get a probability of 1/6. Okay. Now, keep in mind, this video was intended to just be a very general overview. Okay, so to kind of recap, probability is the measure of how likely an event is to occur. It's measured as a number between 0 and 1. 0 means it never happens. 1 means it's absolutely going to happen. And if you're dealing with probabilities closer to 0, they're less likely to occur. Probabilities closer to 1 are more likely to occur. We can also write probabilities as percentages and fractions. Now, you've got 3 things that are occurring when you're dealing with probability. You've got a trial, an event, and an outcome. So the trial is kind of like the overall experiment. What are you doing? Are you rolling a die? Are you flipping a coin? Are you drawing cards from a deck? Are you selecting marbles from a bag? What are you doing? The outcomes are all possibilities. How many ways can you roll a die? How many ways can you flip a coin? How many ways can you draw a card from a deck? How many ways can you select a marble from a bag? The event is kind of like the specific outcome we're looking for. So what is the probability of specifically rolling a 2, specifically rolling an even number, specifically rolling a number greater than 4? What is the probability of specifically drawing a heart from a deck of cards or drawing a face card? Whatever the case may be. So the event is kind of like one isolated outcome. Like, what is the probability of that happening? Next, we talked about the fundamental counting principle. From what I can see in Ed Ready for you all this semester, there's not a ton with the fundamental counting principle, but it's one of those things, if you don't know how to do it, it's kind of a pain in the neck. So basically, the fundamental counting principle allows you to easily figure out the total number of outcomes when you're looking at 2 or more events. And then we just looked at examples. We did really simple, quick examples of rolling a single die. We did grabbing marbles from a bag. We looked at the lunchbox example where we did have to use the fundamental counting principle. We looked at rolling 2 dice, okay? And again, if you do have questions that come up where you're rolling 2 dice, it is worth taking a minute to list out these outcomes so they're sitting in front of you. We also looked at rolling a die and flipping a coin, and then we looked at rolling a die and flipping 2 coins. Do read the question carefully if you're flipping multiple coins, because you could flip 2 coins at once and the outcomes are different than if you flip 2 coins separately, okay? So just be really cognizant of kind of like what the wording is needing you to do, okay? So I hope that helped. If not, let me know and we'll kind of like go back to the drawing board, okay? And if this really didn't help at all, please let me know and we can meet up on Zoom and talk. All right, good luck.